Yes, sir.
Okay, so we're gonna be dealing with it forms part and parcel of our trigonometric section. So after this section, the only thing we'll be left with it's 2D interpretation of trigonometric figures. There will only be one section which I will cover it next term. But yeah, this is this is your last section of trigonometry for both term one and term two. And remember that for the June exam, you are required to know everything you learned in term one and everything you learned in term two. So please remain up to date. And those who recently joined, please remind me to send you the links for last term's videos. Right? Yes.
Yes, sir.
Yes. So let me go on to what you are doing today. So here it's basically the introduction to sketching and interpretation of trigonometric functions. So here I said the three basic trig functions. So I'm gonna sketch the basic graph of sine x, cos x, and tan x. And I think all of this you must be familiar with from grade 10. Am I right?
Yes, sir.
Okay. So with regards to how I remember it, you guys would make your domain to be something like 30 degrees, 60, 90, um, what 120, 150, 180. Or since it's the basic graph of sine, sorry about that. Let me do this. Okay, let me do this. I'll just add that line. Okay. Okay. So let me just do this. Okay. So normal, okay, we can just do the 90, 180, 270, and 360. Whereby you know that sine 90 is equal to how much? To 1. So let's have our value of 1 there. And then the value of negative 1 somewhere there. So you have 1. Sine 180 gives you 0. Sine 0 gives you 0 also. Sine 270 gives you negative 1. Gives you negative 1. Sine 360 gives you 0. So if in case you join all those dots, you will have a nice looking sinusoidal wave like that, right? That's from grade 10. And then, can anyone tell me why I put 1 and negative 1 as their bounds? Why did I choose 1 and negative 1? Does anyone remember? What are those? Does anyone remember?
So isn't it the appropriate range that we use?
Yes, it's the range. That uh, remember that sine x has a maximum value of 1. It's all because of the amplitude. The amplitude of this function is a 1 there. The maximum it can have is 1. the minimum it can have is -1. Remember that from grade 10. So now let's sketch the one for cos x. Again, we can use the same domain as 0 and 90, 180, 270, and 360, right? So what is sine 0 is going to be 1. Sine 90 is going to be 0. Sine 180 is going to be -1. Sine 270 is going to be 0. Sine 360 is going to be 1. So if in case we join all the dots, you see, that's the shape of cos x. Cos x forms something like a bowl, sin x forms something like a wave. Now let's go to tan x. This one we're gonna use a rather different. We're gonna use 45 instead of 90. We're gonna go in multiples of 45, not multiples of 90. So let's go. Because I know for this one, the nice thing is that I know that, okay, at 90 degrees, so here I know I have an asymptote, right? You guys remember that asymptote. And you have another one at 270. So you're gonna have 180. Then somewhere there you're gonna have 270. And then somewhere there, 360. And then here, let's say we have 45. Here we're gonna have 135. Uh, what is gonna be here? 180 plus 45 is how much? 180 plus 45?
225.
Yeah? 235.
225
235.
and 25. 225.
225. Okay.
Yes.
270 plus 45. 305.
250.
315. Okay. So now in your calculator, when you punch tan 45, it's gonna give you a value of 1. It's gonna give you a value. And tan 0 is 0. So it's gonna give you somewhat gonna give you a shape like, let's do those points. It's gonna give you a 1 and 135 is gonna give you a -1 there. Let's say it's -1 there. It's gonna give you -1. 180 is gonna give you 0. 225 is gonna give you a 1. Gonna give you a 1. And 315. Can anyone type tan 315 in their calculator?
One, sir.
-1.
It's a 1. 315 is a 1.
-1.
Okay.
-1.
Please verify what is tan 225.
1, sir.
225 is 1.
Yes.
135 is -1. 180 is how much?
It's 0.
Okay. So now we can join the points and draw our graph. Must look something like that. It must approach the asymptote but never touch. Must approach the asymptote but never touch. Again, must approach the asymptote but never touch. Again, even this side uh it must up even like this, it must approach the asymptote but never touch. So that's the basic graph. Those are all your basic graphs. All these three. You must know these shapes. So for here, we used let's say a step of 90 degrees. So that we mean the difference between the points in the on the domain is 90, the space between points on the domain. Even here we moved in multiples of 90, so we can say the step that we moved is 90 degrees. What would you say the step that we moved to for tangent function is how much? We moved in terms of multiples of 45. Okay, so that is basically all. That is all. So even here you can basically see that, oh, the amplitude of cos x is how much? Is 1, right? You find, do you now remember how to sketch these basic things? Can I move?
Yes, sir.
Okay. So now let's move to the basic properties of sine x, cos x, tan x. So these basic properties, you must remember them from grade 10, but I'm just gonna go through them a bit before I move on to grade 11 stuff, right? So you remember what is a range? A range is always the what the set. It's a set of y values for which the function is defined. So it's the set of y values where we always find the points of the function, right? So the range of this one of sine x, because there's a 1 here, the range of it is always going to be -1, 1, right? And there's a 1 there and there's a plus 0 there. You see this 1 and this 0. They make this to have it makes this function to have a range of -1 and 1. Let's go back to the basic graph. You see sine x ranges between which y values? It ranges between 1 and it ranges between. So you'll always find this graph between only these two y values. Outside there, there's no graph. Outside those y values, there's no graph here. There's no graph here. So we only find it between. Okay. Again, we go to the graph of cos x. Its range is also between -1 and 1. Let's check. Is that really the case? You see, it's bounded between, you don't find, there's no graph here. And again, below -1, there's also still no graph. You see, you only find the graph between 1 and -1. For tan x, it doesn't have a specific range. Its y is an element of real numbers. Why? Because it ranges it can go up until to positive infinity and it can go to negative infinity. You guys see that? Even here, it's going up until positive infinity. This side is going to negative infinity. So do you understand why we are saying its range is an element of real numbers? Because remember, y is an element of real numbers is the same as saying y is an element of negative infinity to infinity. It's the same. Okay? So this graph, we can find it everywhere. So this means that it can continue up until all the way up. It can continue all the way down as long as it does not touch the asymptote. Okay? So here you can write y is an element of negative infinity to infinity. It's still fine. Then now we go to amplitude. Amplitude by definition, uh, amplitude is just what? Uh, Amplitude by formula, it's just half of the maximum of a function minus its minimum, right? That's what we mean by amplitude. So check if in case I want to calculate the amplitude for sine x. Let's say I say I give you the graph y is equal to sine x, and I say calculate the amplitude. What is the maximum of this graph, sine x? What is the max? And what is the mean? Guys, talk to me.
Maximum is 1 and minimum is -1.
1, -1. So therefore, now if in case I want to calculate the amplitude, I'm just going to say half into 1 minus -1. How much is this going to give you from the calculator? It's just going to give you 1, right? The amplitude is what? Is 1. Mm. Then we go again to, if in case I go to the graph, if in case I give you this graph, f at x is equals to 3 sine x, what will be the maximum of this graph? What will be the minimum? You have to remember this from grade 10, guys. What is the max for that graph?
I think it's 1/3.
The maximum. Guys,
So
what
isn't
do you
it going
think?
to be 3?
It's gonna be 3. Remember, for the last graph, I had 1. Here I had 1. The graph of y is equals to sine x. Here there's a 1. What was the maximum? It was 1. What was the minimum? -1. Now I give you the graph of 3 sine x. What's the maximum, guys? What is the maximum?
3.
What is the minimum?
-3.
Then what is gonna be the amplitude? Gonna be half 3 minus -3, which is just gonna give you another 3. Okay? Fine. Mm, Then I go to the graph of tan x. Can the graph of tan x have a minimum? Let's go. Let's look at the graph of tan x. Does it have a specific maximum or a specific minimum?
No, sir.
So can it ever have an amplitude?
No, sir.
No, sir.
So you will never be asked for amplitude of tangent function. You will never, right? You will never be asked that. So now I'm coming here. I'm going to another concept which is called the period of a function. Okay. Let me erase this. I want to define what is a period. Tomorrow, that's when we are going to be delving deeper into grade 11 stuff. Today, I just want to introduce you guys to, because this is a small topic. We are gonna finish it within a day. It's a small topic. So, period, I just want to give you guys the definition of it. It's just the number. Just know if in case I write a hashtag, I just mean number. Number of degrees of a function to complete a full cycle, right? By a full cycle, there's something I want to define to you. Remember that you have the graph, you have this graph, y is equals to sine x. What is the shape of this graph? It looks something like this, right? Right? Guys, you guys are not talking. Do you guys not remember? Is this not the shape?
It
It
is,
is,
sir.
sir. It is, sir.
Yes, hence I'm asking you, but you guys are not talking to me back. So this is the shape of sine x. And then I give you another function y is equals to cos x. This is normally the shape of it. Something like this. So now, guys, this is what we call. You see this shape? We call it the shape. It's normally the full. This is actually one full cycle. Again for cosine, this is one full cycle. For tangent, for y is equals to tan x. I'm coming. So for the tangent function, what we have is something like this. For this graph to complete a full cycle, it must do something like this and also do something like that. That's when it has done its full cycle. This is one full cycle for the tangent function. Okay? So now let's go back to our diagrams. Mm. How many degrees does it take for sine to complete one full cycle?
360.
Okay, so the period of sine x is always gonna be 360, right? Of the basic sine. Then we go back now to cos x. What is the amount? What is the how many degrees are required for it to complete a full cycle?
360.
360 again. Let's now go back. Let's now go to the graph of tan x. How many degrees does it take for it to complete a full cycle?
180.
Why is it 180? Because check, you look at the interval in which the interval will tell you, check. In this interval, that's where it completes the full cycle. And what is this interval? It's in the interval of x is between 90 degrees and what? And 270. What is the difference between 270 and 90?
It's 180.
It's 180. So that's where it must take these degrees from here to there. So let me go up a bit above. It must take these degrees from here to there to complete. Okay? Do you guys understand? Because even for this one, it took these from there to there. It took from there to there. Are you guys okay?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So you understand why we have 180. So I think so remember that for tan X, you will never be asked to calculate the amplitude, and you will also never be asked to give the max or min. You will never be asked, right? So here now we are going to a bit of shiftings that you guys did. So you're left with 9 minutes. Once this timer finishes, you know what to do. We'll click on the link again, then we'll continue. So in grade 10, you studied some transformations. So changes. Studied some changes of trigonometric functions. Our functions, your function was always defined. The general form of a function was always y is equals to a sine x plus q, or you always had the function of y is equals to a cos x plus q, or y is equals to a tan x plus q, right? That's what you normally had. We normally gave you something like this, whereby A gives us the amplitude change, and then Q normally gives us the vertical shift. And by vertical shift, remember we mean that are we shifting the function up or down? Amplitude change normally affects the max or the min of a function, right? But again, also vertical shift will also contribute to these two, max or min. Vertical shift will also contribute. But amplitude helps us to look at that actually, right? So it's fine. So let's say I give you this graph. Y is equals to 2 sine x, right? Let me give you that basic graph. Y is equal to 2 sine x. What did we say? If in case I make a rough sketch of it, I know that it's gonna look something like this. Here it must be 2, there it must be -2, right? So it must reach the maximum of 2, the minimum of -2. Here it must still be 360, right? So give me the maximum of this function.
2.
What is the minimum?
-2.
Okay,
Negative 2.
okay. So now I want us. So now I want us to now go sketch. I want us to sketch to revise how to sketch graphs of the form a sine x plus q, or y is equals to a cos x plus q, or y is equals to a tan x plus q. Do you want me to teach you guys a shortcut of calculating of making of sketching graphs? You
Yes, sir, please.
Yes, sir.
I'm gonna teach you how to sketch. Do you know how to sketch a graph using a calculator? A calculator itself giving you all the points that you must
No,
sketch.
sir.
You know how to
No,
do
sir.
that?
Yes, sir.
Do you know? We use
No,
the
sir.
table function. in the Casio calculator. I don't know about other calculators. I only use Casio. A good math learner uses Casio. For an example, okay, let's try to sketch this function here without the use of a calculator. Let's try. We're given f at x is equals to 2 sine x minus 1. We must first identify the changes that were done. What was first done? What was done first was to actually now uh, uh, mm, we changed the amplitude by a multiple of 2, right? That's what we first did. So in other words, you can think of you had the graph of like y is equals to sine x first. Then after that, you move to the graph of 2 sine x. And after getting the graph of 2 sine x, then you move to the graph of 2 sine x minus 1. Okay? Then after that, of multiplying by 2, that's when you shifted the graph down by 1 unit. Okay? So let's do all of this. So let's first try to figure. I think the thing that's gonna help you to sketch this is actually if in case we just figure out the minimum and the maximum values. Then you will be fine. The maximum or the minimum. Let's try to do. What do you guys think the maximum is of this function? What is the maximum? Guys?
1, I think.
Okay, another person says 1. Any other suggestion? Any other suggestion? Who said 1? Who suggested 1? There's a learner who suggested
It's
1,
me, sir.
guys. Who
Yes,
suggested
sir, it's me.
it's Nosipo.
Yes.
Okay. Nosipo said 1. Does anyone disagree with Nosipo?
So isn't the maximum value going to be 2?
Okay. That's what I wanted. Another person says 2. Okay. So now we have to evaluate who's correct and who's not correct. Remember, okay, if in case I look at this graph of sine x, what is the maximum of it? Y is equal to sine x. What is the maximum?
2. That's 1.
It's 1. What is the maximum? What now, if in case I now have y is equals to 2 sine x, what will be the maximum of it?
2.
It's
2.
gonna be
2.
2. Now now I get the graph of y is equals to 2 sine x. Now I say minus 1. What is gonna be the maximum?
2.
How did you move from this 1 to that 2? You multiply by 2, right? Because the graph itself was multiplied by 2. Let me explain it down here. We have the graph of y is equal to sine x first, right? Then this is the first function, this is the mother function. Then you move to the second one, y is equal to 2 sine x. Then you get to the third graph, y is equal to 2 sine x now, and then you minus 1. Tell me, what is the max? Here you have 1. You have 1 in front of this thing. Tell me now, what is the maximum of this function? What is the maximum, guys? It's 1. What is the maximum of this one?
2. It's 2.
How did you move to 2? You multiplied this one by how much?
2.
2. Then you got a 2. So now I want to figure out the maximum of this one.